This is the determination of solubility product constants lab. And what we're going to be doing is using EDTA to titrate the amount of calcium in a dilute calcium solution, calcium chloride solution. And then we're going to backtrack to what is in a saturated calcium chloride solution and then get our KSP from that. So we got some more titrations to do here. Let's get started. So we're going to make our dilute solution of calcium chloride, and we have the saturated one, and we're going to be titrating this with EDTA to determine how much calcium is in here so that we can determine how much is in here. And you might wonder why we don't just titrate this, but EDTA is used to determine really low concentrations of calcium. It'd be no way, I mean, we could definitely try titrating this, but we need gallon upon gallon of EDTA solution. Here we won't need as much, and then we can backtrack. We just have to keep track of how much we've diluted it. So first thing is, we put in 400 mils of distilled water into our Florence flask. Okay. And then we are going to put in 10 drops of the saturated calcium chloride. And doesn't sound very scientific, very accurate, but let me just do this first. So 1, 2, 3. But the volume of the droplets are pretty similar to each other. I mean, pretty within a percent of each other each time they come out. This is how these work. The size of this pipette gives off about the same size droplet. You just have to determine what the volume is, and I'll tell you what that is at the end of the lab. Normally what you do is you take just the solution and you put it into something like this, like a graduated cylinder, and fill it up to the 5 mil mark, and you count how many drops it takes. And then you determine how much the volume of each drop is. And again, they're within a percent of each other, so if we know that average volume of each drop, we're fine. So, but we'll worry about that later. I'll put that data for you, the volume per drop. Now we have 10 drops in here, and we put it into water. So you put the water in first so that you can get it nice and mixed thoroughly. But we don't put it all in, not yet. So that's probably pretty good. And then you put in the other 400 mils. And we're going to assume that the volume of the droplets is very small compared to this 800 mils. So when we do the calculation, we won't worry about the volume of the drops and how much they take up in this Florence flask. But the volume of the drops will be important when we backtrack to the saturated solution. So cap this on good. Don't want it to spill. And then you shake this up good. There you go. And that should be pretty good. I'm going to just finish this here and then I'll shake it up some more. But then we have our concentrated, saturated calcium chloride has now been diluted. And we'll move to the next step. So now we got to make the samples. We have 3 runs that we're going to do, and I'm just going to do one on camera. And then we also have a blank. The reason is that we're going to use an indicator that's going to change color to tell us the titration is done, but the indicator contains magnesium that's also going to react with the EDTA. So we have to take into account the volume that will be used by the indicator as well. So that's unusual, but that's what we have to do. So we're going to run one sample with the calcium chloride and one without, and see how much, and whatever volume this one uses to react with the indicator will also be what's used here. So, but let's do this out. What we have is we're going to need 50 mils of the dilute calcium chloride. So we're going to put that in here. Oh, didn't quite make it. Get the rest of the way. There we go. So that's going to go in run 1. Okay, and then what do we need next? We need a 10 mil graduated cylinder, and we want to fill this up with 5 mils of the buffer. This buffer. Ooh, and way over. Yeah, we'll just bring this down. This goes in the waste. Never put it back in the reagent bottle. Anything you take out, even though we're pretty clear that it came from here, you never know. And you don't know what was in the graduated cylinder either, so we don't want to contaminate our bottle. So anything that you don't use gets put into the waste. So this is 5 mils of the buffer. And the blank we'll get 5 mils of the buffer as well. So might as well do that one as we're going. Try to go slower this time. Yep. Good. And so this goes into the blank. So notice we didn't put any calcium chloride in there because that's what we're after. That's what we're titrating. So the blank shouldn't contain what we're titrating. And then we need 50 mils, the 4 drops of the indicator. So 1, 2, 3, 4. Same thing here in the blank. 1, 2, 3, 4. And then we need 15 drops of the magnesium chloride here. How many drops? 15 drops. So we have, make sure I'm getting that right, because a lot of things in this one. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 14, 15. And then same thing in here. So 1, 2, 3, 4, 5, 6, 7, 13, 14, 15. Okay, so that should be everything that we need for both samples. Here's our run 1, and our blank. And I'll do the other 2, but off camera. So we'll have three runs that contain the calcium chloride and then a blank. All right, we're going to titrate the blank first. One thing I forgot, I noticed that I had to add in 5 mils of water to the blank as well. And that's just to increase the volume so you can see the color change better. So that's why, so I put that in. Because without that extra 5 mils, it's a very thin layer. So that was just, it's not necessary to the reaction. It's just to allow you to see the color change better. And I'm going to put in a piece of white paper here too. That'll help. Okay. So now, unlike with the phenolphthalein or phenolphthalein that we use for the acid-base reactions, we're not looking for it to go from colorless to a color, or like one of the earlier labs where it went from an orange color to colorless. Here it's just going to change color. It's going to go to a blue or gray look to it. So I'm going to start putting in and what's in the column is our EDTA. So I'm going to start just doing it drop by drop. And the reaction isn't instantaneous. It takes a little bit for the EDTA to chelate the magnesium and to cause it to take on a different color. So we're going to go slowly and and then watch for that color change. So it's not as dramatic of a color change as we're used to seeing, but it will be noticeable. Okay, you can see that it's changed to a kind of a purple or almost a gray, and this is at 4.5 mils. All right, wanted you to see this. This is about 2 or 3 minutes after I was done with the titrating, so you can see it's deepened in color even more. It's got more of a gray tint to it. So we definitely hit the end point as I thought, and that's what I said, that the reaction takes a little time to come to completion, but we are definitely there, and that's what we should be looking for the other titrations as well. All right, we're going to titrate run 1 with EDTA, and in this one there is calcium. So it contains everything the blank contained, but now it contains calcium, so we know we're going to have to add in at least 4.5 mils like we did the blank, so it should be over that, so I'm going to go a little bit faster. Okay, we're just past the 4.5 mark. Whoops, I'll go too fast here. Definitely changing slightly, so we're going to slow it down. All right, here's the final form of it. It's not quite as dark as the blank, but that's because there's more water in it, but definitely a complete color change. So we are now at the end of the titration of run 1.